In this question we have to find CH2 double bond CH2 pH is treated with chlorine at 500 degrees Celsius temperature. Now this reaction takes place via free radical substitution reaction, and radical is formed at that position where most stable free radical is formed. This is case of allylic substitution. So allylic substitution, allylic radical is formed, CH2 double bond CH and pH. Now this radical is resonance stabilized, and due to resonance another radical CH2 CH double bond CH pH is formed. Now Cl will react with both of these radical to form products. So two major products, two structural isomers are formed in the reaction, CH2 double bond CH Cl pH. When Cl is attached, when Cl atom is attached at this carbon. Now if Cl attached at this carbon, we will get another product, CH2 Cl CH double bond CH pH. Now this product, so optical isomerism due to presence of chiral carbon, so two products are formed, R and S, and now this molecule, so geometrical isomerism around this double bond, so E and Z, two products are formed. So total 4 different products are formed in the reaction. So option A is incorrect, while other options are correct. Two optically active products are formed. Yes, these two products are optically active. The optically active compound formed when also made by can also made by reaction of HCl. Yes, if we react with HCl, now carbocation is formed, and now this carbocation will rearrange, and final product is this finally this product is formed. So C option is also correct. The reaction path is free radical substitution. Yes, reaction takes place via free radical substitution. So B, C, D are correct option, while incorrect answer is A, because total 4 different products are formed rather than 2, and hence option A is correct.